All right, in our previous video, we started to take a look at LeChatelier's principle. Specifically, we looked at the impact of change in the concentration and temperature has on the reaction. So today we are going to look at pressure and a catalyst. So once our system is already at equilibrium and we change pressure or the volume of the container, that will shift the equilibrium if we have gases. So if we just have solids and liquids, it will not impact the equilibrium. So we have to think back to our gas law unit and remember that if we increase the pressure of the gas, that causes a decrease in the volume. Or sometimes they'll just tell you that the volume of the container was decreased. And then reverse, if we decrease the pressure, that would cause the volume of the gas to increase. So you have to keep that in mind. And then you have to look at the number of moles of your reactants and your products. So remember, moles are given by the coefficients, the big numbers out in front. If we have an increase in pressure, that causes the volume of the gas to decrease. So our problem is that it's too crowded. So we would need to proceed to the side that produces less moles of a gas, because then that would help to alleviate the overcrowding. On the reverse, if our pressure decreases, that causes our volume to increase, and all those particles are going to expand out and spread out. So then you would want to make more moles to offset that. All right, so let's take a look at this example here. So here is our reaction, and it's at equilibrium, and then we increase the pressure. So first thing we need to check is, do we have gases? Because if we didn't have gases, it wouldn't impact it at all. So if we increase our pressure, that would cause the volume to decrease. So now we would be too crowded. There'd be too many moles in too small of a spot. So what we have to do is split it in half, and we have to look at the moles of a gas on each side and only count moles of a gas. If you have a solid or a liquid, don't count them. All right, so on the reactant side, over on the left-hand side, we have 3 moles of gases. On the product side, 2 moles. So since my problem is that we're overcrowded in this smaller volume, this reaction would shift to the right, or the forward reaction would be favored, because that would take 3 moles, turn it into 2, so it would offset that overcrowding. All right, now we just have some examples to look at, and so these use some of the concepts from the previous video too. So here's my reaction. It's at equilibrium, so rate of forward is equal to the rate of the reverse, and the temperature increases. So I have too much heat, so I would do the reverse reaction, because that would move away from that excess heat. All right, pressure decreases. So pressure is a little harder. First, I got to check, do I have gases? Which I do. So pressure decreases, volume increases. So now I would need to go to the side that makes more moles of a gas. And if I count that up, I get 9 moles over here and 10 moles over here. So I would be going to the right, or the forward reaction. And then lastly, we add NO. So we were at equilibrium, and then we increased the amount of NO present. So we opened up the container, added more in. That would make the reverse reaction occur, because that would use up that excess NO. All right, second one. Here is our equilibrium. If we decrease the temperature, so my problem is I don't have enough heat, so I would do the reverse reaction, because that would actually produce some of that heat back, or not enough, you move towards it. Okay, if we added the sodium ion is over here, so too much sodium ion, the reverse reaction would occur. We would shift away from that. Now, this is a 2-part question here. If we increased the Na plus, what would happen to the Cl minus? Well, we already said the reverse reaction occurs. So if we are doing the reverse reaction, the Cl minus would decrease, because it's getting used up. So since we're doing the reverse reaction, the Cl minus would be getting consumed, so it would decrease. All right, now we have some more examples. So I want you to pause the video and try these out on your own. And then come back and we'll go over the answers. Okay, so we got our equilibrium and we decrease temperature, so that would drive the forward reaction. So we don't have enough heat, we'd have to make more back, so we'd have to move towards the heat. Again, we're at equilibrium, we open up the container, take out some of the CO2. So now our problem is I don't have enough CO2, so that would also cause the forward reaction to occur, because then that would produce more CO2. All right, increased pressure. This would remain the same because I only have 1 mole of a gas on each side. You only count moles of a gas, so if it's 1 and 1, not going to do anything to the equilibrium. All right, next question. If I increase temp, I'd need to move away from the heat, so the reverse reaction would occur. If I decrease the amount of Na+, I'd have to make more back, so I'd have to do the forward reaction. If I increased OH-, I'd have to do the reverse reaction to move away to use up some of that extra OH-. And lastly, if we add a catalyst, we know that that will increase the rate of the reaction because it will lower the activation energy. And it will actually speed up the forward reaction and the reverse reaction. So therefore, there will be no net change in the equilibrium, other than we might get to equilibrium quicker.